go through every single reagent quickly to try to figure out if you are going to get that aldehyde. Now with A, we're starting with our alkene. Recall this reagent is going to form an alcohol at the least substituted position because it follows anti-Markovnikov's rule, so we're just adding an OH. Now, have we really seen this with an alcohol? No, this does not work. The reason why it doesn't work is because OH is a bad leaving group. Automatically, we can stop and say A is not our answer because the second step does not work. Note, for this to work, we want a better leaving group, so that's going to be some sort of alkyl-halide. Maybe we can use a tosylate. That's a better leaving group. So either one of those will work with this triple bond. Moving on to B, the first step is the same. Now this next portion does work. This forms a better leaving group, so we can apply this. And notice all we're doing is we're adding 2 additional carbons. So think of this as this leaving. We're now attaching on that carbon 1 and carbon 2, so we added 2 more carbons. But the issue here is this doesn't really make sense to use because for a triple bond, that's going to form a carboxylic acid, and we're looking for an aldehyde. Going back to that sort of reagent, remember this is a form of ozonolysis. We specifically have a terminal alkyne, and that forms a carboxylic acid and carbon dioxide. So B is also not correct. Moving on to C, we've now changed the reagent where this is going to add a bromine to the least substituted position, which is here. We do have a good leaving group, so this would kick off, and we're going to add those 2 carbons. Now that we've added those 2 carbons and we now have an alkyne, we're using this reagent, which again is going to form an aldehyde, which is good, but if you notice, we have too many carbons. We end up getting a total of 8 carbons, and remember, we wanted 7. And for D, we still have the same thing we saw in part C. The main difference is now we're doing a reduction step, where we're reducing this alkyne into an alkene, specifically a cis alkene, and then we're going to use ozonolysis. The reason why we had to use ozonolysis is because, like the last example, we would have had too many carbons, and we just want 7. So when we do that, when we cut this down, I know that I will form that aldehyde here, which is the product we're looking for, and of course, we still have that formaldehyde there, but this was what we were looking for. Our answer then is going to be D.